Morning, guys. Mr. Lochan here. I'm at my lab this morning waiting for my microbiology sterilization cycle to cool down before I pour some plates. And I want to accomplish something this morning that's been on my mind for a little while. And I wanted to hopefully bring some light to a very important test called the CBC, FBC, or hemogram. CBC for complete blood count, FBC full blood count, and it's also called a hemogram. This is one of the most important routinely requested tests by a physician. Many of you as patients would probably receive a referral letter from a doctor where this test may be one of the most frontline tests he or she may ask for. Let me give you a little idea over the next couple minutes what really is a CBC and how you can, as a patient, as a student, as a fellow MLT, how you guys can get a refresher or a little more introduction to your blood count. Firstly, blood is made in our bone marrow. All right, even when we were all fetuses inside of our mother's belly, our blood started to be manufactured in the yolk sac and other areas. And when we were born and as we grow, blood has continued to be made in our bone marrow. All right, so that's number one. Blood, or a process called hematopoiesis, is made in our bone marrow. Therein lies the reason why we have many conditions that could develop as a result of improper manufacturing of blood. Classic example, what we call blood cancer, or a group of diseases called leukemia. Leuco from the word white, because the white cells become markedly increased. Anyway, that's just a little overview, but let's go into the most important thing here. Blood is made up of a liquid and a cellular component. When I say liquid, I mean really non-cellular, and as well as a cellular component. All right, your cellular component is made up of three things: your white blood cells, your red blood cells, and your platelets. These are the three formed elements or cells in our blood. All right, so secondary to that, we've got a non-cellular component called plasma. Plasma is basically a transport mechanism. It's usually a pale yellow and clear liquid that is without cells, and it primarily acts as a transport mechanism. All right, for electrolytes, for hormones, for chemicals, for wastes, etc. All right, so together with your white cells, your red cells, and your platelets, those are the cellular components of your blood. You've got a non-cellular component called plasma. All right, so that's number one. In our bone marrow, we've got a very, very interesting cell called a mother cell, or hematology would call it a pluripotent stem cell. Pluripotent meaning it has the capacity to develop into different cell lines. So this pluripotent, or this stem cell, is in our bone marrow and under stimulation by different factors, and these factors are called interleukins, and there are other stimulants as well. Along the differential line, you've got a mother cell, and this mother cell under stimulation will give rise to daughter cells, and these daughter cells under further stimulation will give rise to, for want of a better phrase, granddaughter cells, until you've got your different cell lines, and these different cells will come out into your veins and your arteries and your capillaries, which are your three types of blood vessels. All right, so the maturation process of blood cells essentially begins with a big cell, and as cells mature, they get smaller until they come out into what is called peripheral circulation. Now, somewhere along the line, we can have problems. But let's go back to normal hematopoiesis or blood manufacturing in our bone marrow. Once there's normal hematopoiesis or blood manufacturing, I want to just remind you guys that in any manufacturing line or any assembly line, you must have raw materials. So even our bone marrow requires raw materials, and the most common raw material for hematopoiesis is what? Iron. All right, so that's why a diet that is adequate in protein and amino acids and all of that is essential for blood making. And therein lies, from a pharmaceutical perspective, why many of our blood building tonics has chemicals and additives and enhancements towards hematopoiesis. Okay, so this assembly line in our bone marrow with this pluripotent stem cell that has the capacity to divide and make all the different cell types. It's happening right now in our bone marrow. If there's a particular need, if someone were to lose a significant amount of blood due to a vehicular accident or trauma, etc., or if there are other underlying conditions that would cause us to develop something called anemia, which is really a low hemoglobin, then you will have your bone marrow hopefully stepping in, getting a message to increase production, and then you will have a correction of the anemia. In many instances, there are some instances where the anemia cannot be corrected. We'll talk about that. This is just an introduction this morning. So you've got your one cell line or one cell type, which is your white blood cell. Your white blood cell has 5 different cell types. This machine that I've got here giving us 3 different cell lines, but I want to tell you your 5 different cell types are neutrophils, lymphocyte, monocyte, eosinophil, and basophil. When a doctor asks for a CBC, he or she wants to know initially, one thing they want to know is your white count. Your white count has a normal range of 4.5 to 10.5 thousand cells per microliter. That means in the amount of blood like that, you're supposed to have around 4.5 to 10.5 thousand, 10 to the power of 3, thousand cells per microliter. White cells, that is. The function of your white cell is basically your policeman. Your policeman. And I want to just tell you how I teach this. Your white blood cells are your policemen. The job of the policeman in any country, in any body, is for protection. But in any country, in any organization or any group where you've got defenses and you've got protective mechanisms, you have policemen. For example, there are different types of policemen. You've got traffic wardens, you've got narcotics, you've got homicide people, but essentially different policemen for different jobs. So you have these. Apart from white cells, you've got 5 different policemen that are made in our bone marrow, and they are called neutrophils, lymphocyte, monocyte, eosinophil, and basophils. These different 5 white cells have different functions. The 2 most common white cells are your neutrophils. Out of every 100 white cells, you're supposed to have around 40 to 80% of them being neutrophils. Out of every 100 white cells, you're supposed to have around 20 to 51% of them being. And similarly, out of 100 white cells, 1.7 or 9% out of 100 white cells supposed to be monocytes, then eosinophils and basophils. In a nutshell, these 5 different white cells are all policemen. They play a role in helping defend and protect the body from foreign invaders. These invaders can be of different types. So you've got this first guy here, the neutrophil, whose job primarily is to phagocytize. And what we mean by phagocytize is to engulf or to eat foreign particles, especially bacteria. That is why he is in so much increased amounts, 40 to 80%. Then you've got your lymphocyte. Your lymphocyte, which is a cell that is a white cell but looks different. His job essentially is to assist in the production of antibodies. And what is an antibody? An antibody is a chemical that is produced in our bodies as a result of an antigen. and an antigen is a foreign particle. So through and via the immune response of our body, antibodies are produced by these type of cells. All right, lymphocytes. You've got your monocyte, your eosinophil, and basophil. An interesting thing here about this policeman, the eosinophil, he is normally increased. He is normally 1 to 6% of 100 white cells, but he is normally increased in conditions such as asthma, parasitic infections, and even allergies. So now essentially, and we've got the monocyte and basophil. Basophil you would see is less than 1 to 2%. Monocytes are 1.7 to 9.3%. These values may be slightly different in different texts, but I just want to tell you that your neutrophils and your lymphocyte are your two most common policemen, but they've got very defined specific roles of protection. Together, these neutrophils, lymphocyte, monocyte, eosinophils, and basophils, we commonly called, we use a way to remember them: never let monkeys eat bananas. So in case anybody asks you, what is the order of white cells from highest to lowest, you can tell them, never let monkeys eat bananas, which is neutrophils, lymphocyte, monocyte, eosinophils, and basophils. White cell count, policemen, 5 different types of policemen with different jobs, and these different policemen, guys, these different policemen are produced in a normal patient differently based on the type of criminal activity that is being done. A patient with a diabetic ulcer or an infected wound from a bacterial cause will more than likely have an increase in neutrophils, because his job is to phagocytize or to engulf or to eat bacteria. Somebody with a viral illness may have an increase in lymphocytes, because the lymphocytes aid in antibody production. Somebody with a parasite like worms, in my classes I say worm, but somebody with a parasitic infection, allergy, may have an increase in eosinophil counts. Now, that's the white cells. All right. Why you see here lymphocyte, monocyte, and granulocyte. Granulocyte, site in medical terminology, is a word for cell. But you've got granulocyte, meaning a cell with granules in its cytoplasm. All cells, guys, all these blood cells, apart from the red cell, they've got a nucleus, and in the nucleus, outside of the nucleus, actually, you've got a cytoplasm. This cytoplasm has granules, or it may not have granules. There are 3 policemen that has granules in their cytoplasm, and they are the neutrophils, the eosinophil, and the basophil. So the neutrophils, eosinophil, and basophil are called your granulocytes because they've got granules in their cytoplasm. The lymphocyte is an agranular white cell, as well as your monocyte, which is an agranular or without granules. So this machine gives a 3-part diff, or a 3-part breakdown of the total white count. That is an introduction of your white count there. And with respect to your next cell type, which is your red cell, my goodness, look at it. The white cells were 10 to the power of 3 per microliter. Microliter, as we said, is a very small amount of blood. But now we've got our red cell, which is 4 to 6 million cells per microliter. So of course we can see that the most prolific or the most common blood cell is your red cell. This here is your red blood cell count. Your hemoglobin is found in your red cell. Your HCT, which is called hematocrit, is also called historically as your PCV, your packed cell volume. Your MCV is your mean corpuscular volume, which is the size of your red cell. In your bone marrow, your red cell is supposed to be 6 to 8 micrometers big. In patients with anemia or anemia due to lack of resources, etc., you can get smaller red cells and that will be seen by your MCV being low. Okay, so that patient will be called microcytic. Okay, the MCH and MCHC basically deals with the amount of hemoglobin and the concentration of hemoglobin in the red cell of the patient. Your PLT is called your platelet. This is the 3rd cellular component of your blood. let's just recap here. Your white cells are your policemen, and there are 5 different types. Never let monkeys eat bananas. 5 different types, 5 different jobs, and combined they protect us from foreign invasion. Then we've got our red cells, whose job is to primarily transport, okay, transport gases at the level of the lung. So there's the cardiac cycle, where blood is pumped to the lung after going around across and around the body. That blood cell becomes low in oxygen at the level of the lung. Gaseous transfer occurs, where carbon dioxide is released and oxygen is simply taken up. That oxygen or oxygenated red cell goes back to the heart, and the heart now pumps it to the rest of the body, right? Because any tissue, cell, organ, or body system that is without oxygen is gonna die or suffer as a result of low oxygen levels. All right, therein lies why a cardiac arrest, a heart attack, a stroke is very important, because once there's a stroke, there's a rupturing or a bursting of a blood vessel, even if it's on the heart, and these areas that are supposed to be fed by the blood vessels are starved. And therein lies the reason why certain body parts are affected as a consequence of stroke. And heart attack is death to piece of a heart muscle. This so important is your red cell. These are your red cell parameters, all these. Then lastly, we've got your platelet, where 150 to 450,000 platelets are supposed to be found in 1 microliter of blood. Your platelets are the smallest circulating cells. Some patterns of thought say that it is not actually a cell, it is part of a cell. It is a fragment, a breakaway fragment from a large cell in the bone marrow. Nonetheless, the platelets play an important role in assisting clotting or helping coagulation take place, and there are disorders related to coagulation as well. So let's summarize before we move forward. Your CBC, also called FBC for full blood count or hemogram, is basically a check of your blood. But when that blood is being checked, the doctor wants to know your white cell count, of which there are 5 different white cells: neutrophils, lymphocytes, monocytes, eosinophils, and basophils. And then there are your red cells, whose job is to transport gases, and these are your red cell parameters, all of which are important in helping your doctor understand your blood count, because you can have anemia caused by different things. And then lastly, your third cellular component of blood is your platelet, or what is called your thrombocyte. The medical name for white blood cell is leukocyte. The medical name for red blood cell is erythrocyte, and the medical name for platelet is thrombocyte. So with that, that's a little synopsis of your CBC, friends, and it will help you to better understand what's going on. But in a nutshell, your white blood count is one of the most important parameters. Your red blood count and your hemoglobin is one of the most, as well as your platelet. When your physician sees your CBC result, he or she is going to look at your hemoglobin, your hematocrit, your MCV, your MCH, and assess if there's anemia, what kind of anemia is present. I want to just let you know that not all types of anemia. Anemia is classically identified or classically defined as a low hemoglobin. Anemia is classically defined as having a low hemoglobin. 12 to 18 is the normal international reference range for hemoglobin. And however, once you've got a low hemoglobin, you can be identified or defined as having anemia. But my friends, I want to tell you that not all types of anemia is as a result of iron deficiency. So once your blood count is low, it does not mean that you have to automatically go and get iron supplements, because you can go into iron toxicity and you can be throwing water on duck back, like what they say. The reason for that is because not all anemia is caused by iron deficiency, even though iron deficiency is the most common form of anemia worldwide. How it is recognized is by patients having a low MCV. A low MCV meaning the red cells supposed to be this size and they are this size, smaller, right? Because it is a production issue. All right, there's lack of resources. But then there's a quality issue, my friends. There's a quality issue. Persons with genetic abnormalities like sickle cell, which is an inherited blood cell disorder, the person's red cells are supposed to be rounded and they form like a sickle, right? And that sickle is that agricultural tool that is bent and what we use to cut grass. So that's why they get it. They get the name sickle cell. But that is not a production. That is not a resources issue. That is a quality. The quality, right? So there's a genetic. All our major processes in our body is under genetic control. But if the genetic prerequisite is abnormal, you're gonna get a resulting protein that is abnormal, and that is sickle cell. There are many other types of abnormal hemoglobinopathies. Hemoglobin, which is the pigment in your blood, and then pathies from the word pathological, which means abnormal findings, which is why the CBC remains a very important test. Okay, I urge everyone to submit themselves to their physician's guidance and get a CBC done on yourself regularly, at least once per annum. If you are already anemic, you will be partnered with your physician, and he or she will help you in managing that anemia and finding out the root cause. Okay, what do I desire to tell you again here? In a nutshell, I think this is about it for this morning. I wanted to introduce you guys, especially the young women who probably with polycystic ovarian syndrome, probably women who are not eating properly, and I think to encourage yourselves to know your blood count. All right. So this is an introduction. I know I've spoken a little bit fast, but you can probably just slow me down and listen to it a little bit better. If I've made any errors, forgive me, but I wanted to introduce you to the CBC, let you appreciate that it's a white cell count, which are your policemen, 5 different types of white cells, each with their own defined function. And here it is, based on what your medical condition is, you can have different increases of these policemen. If there's a particular criminal activity happening in the country, a certain specialty type of police man or force is going to be put into or out there to do their job. Similarly, so, which is why you've got to have a good function in bone marrow and feed yourself properly with diet, etc. And that's a beautiful phenomenon, a beautiful thing that occurs in our bone marrow, hematopoiesis. And it's so wonderful it occurs even while we were in our mother's womb. Therein lies the beauty of creation and the power of God in even something as beautiful as his creation. So I just wanted to share that with you. If I've omitted anything, probably look towards us for some future information. All right, so keep well, guys, and God bless you. Live well and keep on top of your game with respect to your health.